Hello guys, and welcome back to the course. In today's lesson, we are going to keep on digging on trigonometric functions, but today's lesson is going to be about equivalent representations of such functions. Let us have in mind the following right triangle with sides A and B and hypotenuse C. According to the Pythagorean theorem, we know that a squared plus b squared is equal to c squared. Now, if we consider the angle theta and we start using the trigonometric functions, we know that sine of theta is equal to opposite over hypotenuse. Thus, sine of theta is equal to b over c. As well, cosine of theta is adjacent over hypotenuse. Thus, cosine of theta is equal to A over C. Thus, sine square of theta plus cosine square of theta will be equal to B squared over C squared plus A squared over C squared, which can be simplified as b squared plus a squared divided by c squared. But according to the Pythagorean theorem, we know that b squared plus a squared is equal to c squared. So we can substitute this in our last equation, and we get that sine square of theta plus cosine square of theta is equal to c squared over c squared, which is equal to 1. And this is the first trigonometric identity that you need to have in mind. Sine square of theta plus cosine square of theta is equal to 1. From this trigonometric identity, we can generate two more. If we take this identity and we divide by cosine square of theta, both sides of the equation, we get that tangent square of theta plus 1 is equal to secant square of theta. And the final identity that we can get from the identity sine square of theta plus cosine square of theta equals 1, we can get it by dividing both sides of the equation by sine square of theta. If we do so, we get that 1 plus cotangent square of theta is equal to cosecant square of theta. Two other identities that will be very useful are the following. Sine of 2x is equal to 2 times sine of x times cosine of x, and cosine of 2x is equal to cosine square of x minus sine square of x. These two identities are called the double angle identities. Now, let us start using the trigonometric identities that we just learned for simplifying trigonometric expressions. Let us start with the expression tangent of theta times cosine of theta. First of all, we know that tangent of theta can be written as sine of theta divided by cosine of theta. Thus, tangent of theta times cosine of theta is equal to sine of theta divided by cosine of theta times cosine of theta. And we can simplify this expression as sine of theta because we can cancel out the expressions for cosine of theta that appear both in the numerator and the denominator. Another expression that we can simplify is the following: 1 plus sine of x times 1 plus sine of minus x. Now, as sine is an odd function, we know that sine of minus x is equal to minus sine of x. So our original expression is now 1 plus sine of x times 1 minus sine of x. But now we have a difference of squares. So this can be written as 1 minus sine square of x. But remember that sine square of x plus cosine square of x is equal 1. So if we solve for cosine square of x, we get that cosine square of x is equal to 1 minus sine square of x. Thus, the original expression can be written as cosine square of x. Let us consider this new expression, secant square of theta minus 1 divided by secant square of theta. Now, one of the identities that we learned in this lesson is that 1 plus tangent square of theta is equal to secant square of theta. Thus, if we solve for tangent square of theta, we get that tangent square of theta is equal to secant square of theta minus 1, which is actually what we have in the numerator. Thus, this expression can be written as tangent square of theta divided by secant square of theta. Now, tangent square of theta is equal to sine square of theta divided by cosine square of theta, and secant square of theta is equal to 1 over cosine square of theta. Thus, this can be rewritten as sine square of theta times cosine square of theta divided by cosine square of theta. And if we simplify this expression, we get that the original expression is equal to sine square of theta. Let us do a final simplification. Let us consider the expression cosecant square of theta minus cotangent square of theta. We know that cosecant square of theta is 1 over sine square of theta, and cotangent square of theta is equal to cosine square of theta divided by sine square of theta. So the original expression can be written as 1 over sine square of theta minus cosine square of theta divided by sine square of theta. And as we have the same denominator, we can simplify this as 1 minus cosine square of theta divided by sine square of theta. But the numerator can be rewritten as sine square of theta divided now by sine square of theta, which is equal to 1. Remember that we can do this substitution, 1 minus cosine square of theta equals to sine square of theta, because this comes from the identity sine square of theta plus cosine square of theta equals 1. Well, guys, that is it for today. Thank you very much for following this video until its very end. Now it is time for you to practice, and I challenge you to simplify the following trigonometric expressions. And as always, see you in the next lesson.